Hi Dhirubhai kids, welcome to Doubt Shout. We know that you have your international maths exam on 10th of November. So we are launching a series of videos to address and solve all your doubts before this. To kickstart, we are going to solve few important questions from previous year question paper, which we think are most likely questions to appear in our paper, or something like this for sure will be there in our paper. Maybe like some concepts here and there, but a question on this topic, which is functions, is most likely to be there. So let's start. To begin with, I have taken this question which is there on function and has been taken from the past year paper May-June 2022. The first part of the question reads that we have to plot this function on the diagram, and the diagram has a fixed grid, fixed domain from -3 to 3 and a fixed range from -10 to 20. So you can simply pick up your GDC, put this equation on a GDC and make sure that you are just capturing all the important features of the graph and plot it here. It should be a simple sketch. To show you the same thing, I'm gonna take this equation in Desmos and show you how do you plot it. So the equation is x raised to 3 minus 5x plus 3. The domain of the graph should be at -3 till +3, and the range is from -10 to 20. You have to exactly capture this graph. Just to be very sure, I'm just going to take the y-intercept, which is at 0, 3, and also I'm just like zooming out to show you that what is the value at x equals to -3 and x equals to +3. So I'm just adding a random line here, x equals to +3, so we can see the y value out here is 15. I'm also putting x equals to -3, so I know that the value of the function is at -9. This is the exact graph to be captured, which is in between the two vertical lines on my screen with these endpoints. So let me copy this graph. Here we saw that 0, 3 was the y-intercept. Then the graph is going down with some minimum point and it was approaching upwards, and the graph is ending at 3, 15. Similarly, we have a exact similar graph on the other side with the minimum point, which is nearly at -3 and at -9. So this has to be the graph that you can directly copy from your GDC screen. Now part B is asking you about the coordinates of the local maximum point. On your GDC, go to GSolve, which is F5, and look for the maximum point. It will give you this maximum point. I can see from the Desmos screen the maximum point is at -1.29. 7.3 is the value. So -1.29 and 7.3 is the coordinate of the local maximum point. Also, I have taken these coordinates till 3 significant figures. Make sure that you also round off your answers to 3 significant figures. The next part is describe fully the symmetry of the graph of y equals to f of x. The graph clearly is not symmetrical about any vertical or a horizontal line. The graph seems symmetrical about one of the point on the graph. In case of the symmetry of the graph, which is for 3 marks, you have to mention 3 things. First thing, that it is a rotational symmetry. And from where? So you have to also mention the center of rotation. And the next thing you have to mention, that what is the degree of the rotation. So we can clearly see that the graph can be rotated like this to get you the symmetry at 0, 3. But what is the degree of the rotation? So we can do this twice in this entire 360 degree. Therefore the degree of rotation remains just 2. And center of rotation, you can clearly see it at 0, 3. And it's a rotational symmetry, so mention that too. The next part of the question says find the zeros of the graph. Zeros are basically the x-intercepts. Again, you can press G solve F5 and go for the x-intercepts. Let me show it to you on decimal screen. The x-intercepts are at minus 2.49. Let me copy that. So x is equals to minus 2.49. The other x value is at, the other x-intercept is at 0.657. So 0.657, and then the third x-intercept is at 1.834, taking it till 3SF. 1.83 is the third root. Basically those are the zeros, roots and x-intercepts, same thing. 3 marks, 3 x-intercepts. Moving ahead to the next part. Now we are supposed to plot another quadratic equation on the same diagram for 2 marks. So let's go to your GDC. I'm going to Desmos and enter the equation. The equation is x squared minus 2x plus 2. X squared minus 2x plus 2. Make sure that I'm plotting this graph between minus 3 and 3 only. So I could see that it ends at 3, 5, then minus 3, 17, having a minimum point at 1, 1. So the left hand side is at minus 3, 17. The right hand side is at 3, 5. So going to the same graph, I'm taking a different color here. Minus 3, 17 is one of the point where the graph ends. Then the parabola also has a minimum point at 1, 1. We saw it from the graph, and the graph ends at 3, 5. So basically a parabola goes like this, something like this, which is gonna pass through all the 3 points, and definitely this point is the minimum point. 1, 1 is the minimum point. Let's just cross check it. So minus 3, 17 I said was a point, 3, 5 and 1, 1 is the minimum point. That is it for 2 marks. You have to show the minimum and the 2 endpoints. Then last part of the question says that use your graph to solve a random equation. Though this equation looks pretty big, it has an x cubed term, x squared term, minus 3x plus 1. But if we look at the previous equation, which is x cubed minus 5x plus 3, and the other equation which is x squared minus 2x plus 2, this equation can be solved through these 2 equations only. The very first guess you have to take is that equate both the graphs and check after equating are you able to get back to this equation or not. Let's do that. So we had x squared minus 5x plus 3. Basically, I'm taking when does f of x is equal to g of x. So when does x squared minus 5x plus 3 is equals to x squared minus 2x plus 2. When we solve this equation, we get, sorry, the previous part has x raised to 3. I will change this. So we will get x raised to 3 minus this x squared on the other side. Then minus 2x moves to the left hand side, gets added to minus 5x. We will be getting minus 3x. This 2 gets subtracted from 3 on the other side. We get plus 1 equal to 0. And that's what exactly they are asking. X cubed minus x squared minus 3x plus 1 to be 0. So technically they are looking for the points of intersections. Look at the point of intersection from your GDC screen. So we get the point of intersections are at the x values only though. Those are at minus 1.48, 0.311. Let me copy it down. Minus 1.48. X is equals to minus 1.48. X is equals to 0.311. And one more value of intersection point is when x is equals to 2.17. So these are the 3 intersection points for 3 marks. This is it. We have completed this 15 marker. Pretty good for this session. So I'm putting this PDF in the description section. Please note we have a free live doubt solving session on 6th of November. That is in like a week time, basically on this Sunday. I'm going to cover 1 hour crash course on functions topic only, followed by 1 hour doubt solving session. Please check the description box for more details. Also do hit like, subscribe if the video was helpful to you. Do put your doubts in the comment section, and we promise that we will address each of those doubts. Thank you so much. See you on the other side.